Here's integrated 3. It's problem 12-68. It's the one about the marbles. It says, Mary has an antique marble collection containing 40 marbles. She has 5 more red marbles than blue marbles, and twice as many red marbles as green marbles. Write a system of equations and determine the number of each color of marble. So the way I started this is I noticed that they had some statements that were comparing the marbles to each other. Like the very first sentence says there's a total of 40 marbles. So from that I can get that the red plus the blue plus the green is 40. There's only 3 kinds of marbles, and she has a total of 40 marbles. So all the red marbles plus the blue marbles plus the green marbles must equal 40. So that was one of the first things I noticed about it. But the trickier part is when they compare the red marbles and the blue marbles. So it says she has 5 more red marbles than blue marbles. So I'm going to cover up the 5. So if I do it like this, I've got red equals blue. And that's how I actually did this, is I asked myself, are the red marbles and the blue marbles equal? No. The problem tells me that they're not equal. It says there's 5 more red marbles than blue marbles. So the temptation is to put the 5 over here, but that won't work. Because there's more red marbles than blue marbles, you've got to put the 5 on this side. There's more red marbles than blue marbles. The blue marble number is smaller than the red marble number, so I'd have to, whatever the blue marble number is, I'd have to add 5 to it to make it equal the reds. So I hope that's not too confusing. But that's one of the equations that you're going to get just from reading the words of this word problem. And then right after it says that, it says, there are twice as many red marbles as green. So again, I do the same exact thing, cover up this little 2. I write a red and a green with the equal sign in between them, and I say, are the reds equal with the greens? No, they're not. It just told me that there's twice as many red marbles as green. So who gets the 2, the red or the green? We know somebody gets a 2. You'd think it would be the red because there's twice as many, but that's not true. We got to put the 2 with the green because the red number is such a big number that if I didn't put a 2 on the green, there'd be too much over here. There's a lot of red. I need to multiply the green number by 2 to make it equal the red. I hope that also makes sense. So these are the 3, these 3 boxed ones are the ones that are that's like the math that I got out of all those words in the word problem. Now we just have a system of equations. So I started by looking at this one, and I thought, well, I have to eliminate some of these variables. So I already had up here that red is equal to 2 green. So in this equation, I substituted 2g instead of r. See? And then I combined the 2g plus g, and I got 3g plus b equals 40. And then you're thinking, well, how's that going to help? Well, I can do something with these 2 equations. So with these 2 equations, if I just put the 2g over here for r, like do a substitution, or you could say it's the equal values method, these 2 equations combine to get this. And then if I subtract b on both sides, I get this equation. So now I have this little equation and this little equation. You'll notice I can write them next to each other like this. And I'm allowed to add them to each other. And if I do add them to each other, the b's are going to cancel out. So then I would have 5g equals 45. And I know 5 times 9 is 45. So I know g equals 9. So now I know how many green marbles there are. And so if there's 9 green marbles, 2 times 9, there must be 18 red marbles. And if I want the blue marbles, I can say R minus 5 equals blue. So 18 minus 5 equals blue. So 18, so I think that gives me 13. So 13, there we go. And then if I added those all together, hopefully they'd add up to make 40, and they would make all these equations true.